Okay, so it sounds most people are interested in the script rails and loops, but I will go through the other material just to check that that we're up to speed, because of course you can't do any of the stuff later on unless you can read and write. You can obviously read and write files. So what I'm going to do is very quickly I have to share the correct window. No, sorry, making a bit of a mess of this. Fine, so you should be able to see. So thanks for that, Paul, that was very useful. So here I am. I've just had something as some kind of notification. Okay, fine. Sorry, I got a notification, but I think it was a spurious one. So okay, fine. So what we're going to do here is how to create and edit files, how to copy and delete files, and also to learn to use the Nano text editor. There's a whole bunch of text editors you can use, but Nano is a reasonably straightforward one. So hopefully you'll be looking at the writing and reading files section. And so we want to go back to our home directory, which is where I started, and let's create a directory called HPC test. And if I ls-f, we can see that we have an HPC test directory. I'll go into HPC test. So we should now go try and create a file in this directory. And a useful editor to use is something like yes, that's fine, that's correct. We can maybe do that. I just wanted is to use a text editor like Nano. So if we use Nano, we can use a file in draft.txt. Okay, and we want to then we can just type what we want, publish or perish any more. You're going to see how bad my typing is. It's share and thrive. Okay. And then to Control O, whoops, I did the wrong thing there. I want to cancel that. To save a file, Control O saves the file. Control O and it'll ask me for file name, draft.txt, and Control X kills it. Okay, so that's a fairly straightforward way of creating a file, and we can, that's useful, and we'll use that for creating any files that we have in the future. Sorry, I'm just having a slight confusion with my Windows. Apologies about this. I just need to find the, okay, I've got it there. So Matt was saying wait for a second to catch up. I don't know, what did you need to catch up on, Matt? Sorry, you need to get logged back in again. Sorry, I had a notification. Now there are other text editors. You can use Vim, maybe not as user friendly. Okay, fine. It put this back up to speed. You can use Vim. There are other emails editors like Emacs and such like, but we only just started. We're really just there. And if you want to look at the contents of a file, you can just use, and I think I've used this command before, you can just use cat. So if we cat draft.txt, you'll see that we get a file there. Now, actually, it's interesting. We can ls-l draft.txt, and we see that it is 64 bytes long. Now, just to talk a bit about the philosophy of Unix. In Unix, everything is a file, but particularly a lot of Unix is based on text files, and text files are literally text files. They contain nothing but, printable characters, A to Z. There's no font information, there's no additional formatting, it's just text. So you should be able to actually work out how long it is. So if we count the letters, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, if we we can 64. That is saying that there's actually 64 characters in that file. Let's see if that makes sense. Nano draft.txt. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, 50, 1, 2, 3, 4, 5, 6, 7, 8, 9, 60, 1, 2, 3. So actually, I think it's only got 63 characters in there that I can count. So anyone hazard a guess why? Whoops, I'm doing the wrong thing here. Anyone want to hazard a guess why there seem to be 64 characters in there when actually I've only got 6 seem to appear. I think I've maybe not counted it quite right, but there seems to be, the file seems to be longer than the number of characters. So definitely the file is 64 bytes long. Yes, there's end of file and there's new lines. So yes, so there's character return in your file. I think I miscounted that, probably 62. So there is stuff in there, you know. If I cat draft.txt, you'll see that it knows there's a character return after the comma, so that must be a character, and there's probably an end of file on there as well. So I think I miscounted. There's probably 62 characters in there. Okay. We can cat obviously. You can cat more than one file, so I can actually cat draft.txt twice, and there we see it comes out again. Okay, you can edit multiple files in Nano as well, and move between them. So that's a useful thing to do. Well, if we do now, we can create another directory, and to move things around, we can. And in Unix, in Bash, it's move. So if we want to move a file, we move it. Now, move does two things. It can rename a file, or it can move it to a different place. So actually, what I'm going to do is I'm going to rename it. I'm going to rename it from draft.txt. Okay. And new name.test file. And so if I go to ls now, it's now called new name.txt file. Now, Manus is asking, use less for cat simply just, well, okay, so in the more with the original, cat just concatenates it to the screen. So if it's got multiple pages, they whiz past, you can't see them, okay? More and less allow you to page through. We won't see that with draft.txt, it's not long enough. But if I have a bigger file, well, we can do that later on. So more was the original thing. I didn't think more didn't used to let you go up the way. So less, yeah. So that's exactly it. Cat will just concatenate the whole, dump it to the screen. Whereas more and less is the modern one, allow you to go up and down, and also to search. So they're halfway to a text editor, actually, more and less. They allow you to search for things and such like. So to copy, now there is somebody mentioned here that we should point out that file extensions are arbitrary. That's true, okay? And you know, there is nothing, a file name is just a text string, and you can call things what you want. They don't have to have an extension. So in principle, file extensions are arbitrary. However, more and more there is convention. So I would always call text files, and a lot of modern programs will actually, you know, expect. So for example, if you're using a GUI interface, your GUI file browser will rely on the extension, and this is true in all operating systems, will rely on the file extension to launch an application example. So although it is true that formally file extensions are completely arbitrary, more and more a lot of subsidiary things start to depend on them. So if there is a convention for a file name, I would probably use it. So for example, yeah, so you know, I would call a text file .txt, for example, and move to remove files. Okay, we can rm. So if we do ls rm new name.txt, which is for remove, and we do ls, we see we've got and I don't have a I think I missed a step here, so I'm going a bit too fast. Okay, fine. So so we now have if I maybe create mkdir documents. Okay, so we have documents and files. Okay, and if I do ls minus lr, it lists them recursively. And we can see that let's yeah. Now the if I want to maybe go to documents, I think I've slightly nano draft2.txt. If we look, if I go up one again, we can see, there we are. So we have documents and files, documents. Now, in Unix, to remove a file is rmdir, okay? That removes the directory. But actually, it's complained there. I've actually done it slightly differently from the instructions. Apologies from that. That actually, you can't, rmdir just removes the directory. And actually, if it has files in it, then it won't work. And so if you want to remove something completely, you do rm minus rf. Now, this is a very, very dangerous thing to do because it does recursively. The R is recursive and F is forced, so it doesn't complain about anything. It will recursively remove documents and all its contents. And if you see, I'll share the other screen for the moment. There's a nice little in the documentation, you'll see that the Steam is a major online platform for games, and you'll see the stories. In January 2015, user Kevin on GitHub reported that Steam's Linux clients had deleted every file on his computer. And what happened is one of the Steam programs had added this following rm-rf $steam root /star. We'll come to files and to variables later on, but Steam root wasn't initialized. This evaluated rm-rf/star, and every single file on his computer was deleted, because that's saying recursively delete. Now, the user shouldn't have been logged in as root, but I mean, you do need to be careful about rm-rf*. So it is a weapon of last resort. So the fact that rmdir just removes the directory and not the files, you might be able to. I don't know. That's an interesting thing. Can use ---- dry run. You might be able to. What I would tend to do is ls minus lr, which I mean, if I wanted to find out, what's gonna, if I was going to do rm minus rf, I'll go back to the window. I would always check with an ls first. So dry run, I don't know. Dry run is often an option which in certain Unix commands, like I'm not actually sure if it's there for rm, because I'm very old-fashioned and a lot of these commands have moved on since I first used Unix 35 years ago, it will tell you what it is going to do without doing it. So ---- dry run is in some commands will say, look, if you edited this command, I would do these following things, and then you can say that's fine. I want you to do them. So does anyone know if there is a ---- dry run? I could look at the man page, but no, I don't think there is a dry run. Okay, there doesn't seem to be a dry run, but I would always do an ls minus lr before I did an rm, just to be careful. So to look at files, often it's not. So yes, the I minus I, as Juan is saying, is a very good. F forces things and doesn't complain about anything. Minus is the opposite. Minus I is interactive and it will prompt for everything. So in fact, I always do rm minus I when I do. We'll see with wildcards. If I always do. If I did rm minus I star, that looks a bit dangerous, but it says, do you really want to remove that? No, I don't. No, I don't. No, I don't. Okay. So rm minus I is interactive, and that's actually much safer to do. So look at files. We've talked about the cat, but people have mentioned more or less. So let's just briefly go through them. There's this thing called there's a file called bashlesson.tar, and you'll see that we should be able to get it. I'll maybe make a directory called bash lesson just to keep things. And I want to, you see there's a come up with wget. Whoops. Yes, I copied the entire command, including the $. So you'll see in the instructions we get this bash lesson, and if we do I'll do an ls. We'll see we've got this bash lesson.tar.gz. A tar is a bundle. It's like a zip file, but it's not compressed by default. So .gz is a zipped version of a bundle. And if we want to unpack it, the command in Unix is tar -xvf. And if I hit tab, it completes it. So I can unpack that. So now we've got lots and lots of files. And what's the issue with these files? Well, if I do ls minus lh, you'll see that they're megabytes long. Okay, so if I catch one, let's do it. Well, let's do the gene association.fb. Whoa, page upon page upon page of stuff. It's not very useful. I'm gonna have to control C that. Yeah. So we can look at various ways of doing it, and useful points are we could nano this file. What did I say? I could nano it. Okay, there we are. I'm really bad in nano. Okay, we could rename it, but also a useful thing are more or less head and tail. So head is very nice. It gives you the first 10 lines of the file. Tail gives you the last 10 lines. HL, which one am I doing? Gene association.fb. Okay, that's the last 10 lines. They're wrapping, so it might look more lines than that, but they're actually wrapping on the screen. If you want to get the fifth line, I often do head -5, pipe to tail -1. I haven't done pipes yet, but you can chain commands together. We'll talk about this later. That gives me the fifth line of the file. But less is nice. Less allows you to page through. You can hit spacebar to go down. You can U goes up. Okay, so that's very, very useful. As it says, you can scroll with Enter or the arrow keys on your keyboard, or I tend to do up and down. With the arrow keys, I use spacebar. It's just a way of looking, and a Q always quits it. That's the most you think. That's what you want to know in less. So I would tend to use less. Look at a file because it allows you to move around. So that's sort of that's really just a zip through that kind of how to manage and manipulate files. So are there any questions people had about that before I go on to the next lesson? It's just really basic. I mean, it is useful to be able to use an in-screen editor. Some people may be using Emacs. I'll maybe do a quick poll actually, just to get some idea of what. Well, no, I won't bother with. I was going to ask people what their favorite editor was, but I think there's probably a few too many options to go through. So VI, yeah, VI. I used, yeah, Vim. It's weird. I first used Unix system in 1985, and I used VI, and I was astonished when I found it was still going. I know it's called Vim now, which I think stands for VI improved. Yes, it was XVF to unpack a tar. So X is extract, F gives us a file name, and V is verbose. If I just basically, sorry, I've lost him. If you look at the man page, if you see here examples, tar -xf archive.tar, v is verbose, which is nice, it tells you what it's doing, and tar recognizes it's zipped. Okay, so you don't need the z. So z is -xzf is probably the formal way to do it, but the modern tar, I mean, commands get more and more. You know, if a command doesn't do what you expect it to do, often they're extended. So nowadays, in the modern tar, well, if it's GZ, it will know it was zipped and it will unzip it. It will unzip automatically. I think Z is for let's find it in here. -Z, filter through gzip. Okay, but it does that by default. So you know, if you try and unpack a tar file which is zipped, tar says, well, it's so how does it know it's zipped? Is it using the file extension, or is it being cleverer than that? That's a very good question. Let's copy. Let's try and fool it. Okay. Let's tar -xvf /lesson.tar. Okay, so it recognized it was zipped. So that was interesting. So file is a useful command in Unix which tries to guess what a file is. So if I do file /lesson.tar, it knows it's gzipped. So it kind of looked at it and said, that looks like a zip file. There's probably some magic header on it. Okay. I was going to do, so one interesting thing about tar is actually, this is a kind of a historical quirk, but I actually type this. Okay. and that works. What looks funny about that command? Why does that look weird? Yeah, but it works. And the reason it works is, does anyone know what TAR stands for? TAR. I mean, we use it for bundling up files, but it actually is an acronym. It actually stands for tape archive. And in fact, it's such an old, this comes from the days in the 70s when you stored data on tape. TAR is such an old command. It was written before they had even settled on the convention that Unix options flags were specified with a minus. Okay, so the reason it accepts XVF, it was written so long ago, it was before the convention of using minus for options had even become standardized, which I think is quite an interesting thing. So what we're going to do now is just go on to the next lesson, which is a few more people were interested in, which was on wildcards and pipes. So this is very, very important, and I will go through it quite quickly because people seem to be most interested in the third lesson. But the important point about Unix is its philosophy is very much that is very much that you, yeah, okay, fine, is that you use simple commands which do one particular things and chain them together, and it's the chaining them together which gives you the power. Okay, so Unix is designed to be a toolkit of simple text manipulation, normally programs that do simple things, but you can build up much more complicated things by chaining them together. So what we're going to talk about in this is how can I run a command on multiple files at once. How can I save a command's output? It just appears on the screen. Okay. So what you should do is you should get that that file. So if you see, I mean, you want to have this bash lesson.tar.gz, which just gives us lots of these big files. Okay. Okay. So we're going to look at some more advanced features, and then one of the most important features about Unix in the way the shell works is the wildcard star. Previously, we have basically just done things on a particular file. Okay, so we could just do ls. Okay, and that gives us all the files. But if I know I'm only interested in the fastq things, I could do ls star.fastq, and that runs the ls command on the only it does pattern matching on all the files which end with fastq. Okay, and the important point is that is done by the shell. It's not ls. ls only that star.fastq is expanded before ls ever sees it. So the ls actually sees all those individual files. That means that if you write your own Unix commands, or he had to do it later on, they benefit from wildcarding as well, because the wildcard is expanded before the command is even called. Okay, so that's actually quite important. Okay, and actually WC is a useful command which does word count. Okay, so if we do WC minus L on this file here, dml all, it tells me that it has 500,000 lines. Okay, that counts the number of, or I could just do WC on it, which is word count, which will give me lines, words, and characters. 500,000 lines, yeah, 8 million words and lots of characters. Okay, but if I wanted to know how many there were on the fast queues, I could do WC minus L star.fastq, and that is expanded. And what I get, what happens is it counts all of the lines individually and adds them up. Okay, so I see I've got, obviously you've got 16 files, and each of them with 20,000 lines, giving me a total of 320,000 lines of output. Okay, so that's very, very useful. Okay, or I could do WC minus L star, which is everything, and I get a number there. And you can use multiple pattern matching ls and WC. So okay, so ls lists the files. So I'm being okay. I'll clear the screen. ls lists the files. WC does a word count on a particular file. So I could do WC on that file there. Okay. But what I said was, by using wildcarding, I could do a word count on all the fastq files by doing that. and it happens to list them as an output. That's just a decision they've made in that file. Okay, and so you can use multiple wildcards. So you can actually okay, so WC stands for word count. So that's a good point. There's a slight ambiguity there. Wildcarding is a general term for specifying something which expands into which does pattern matching. It does a pattern match. But word count, WC is actually specifically using this word count program. Okay. So you can use you can use it on. So I could do WC star.q and star.text as well, for example, which will because there were no matches. Okay, so I didn't mean star.q, I should have done star.q. Okay, and there aren't any texts, but there we go. And it complained there was no star.text. Okay, so it didn't like that, but it did it on the. So you can use it to, you know, if I do an ls, or I can do ls star.tar, ls star.tar star. So that, you know, it's worth playing around with these things to get, but it's very powerful and a very useful way of selecting different subsets of files to work on. But actually, that redirecting output is probably the most useful useful thing you can do. So what I did there, I did WC -L star.fastq. Okay. But I might want a record of that. I want to go away and have a record of these files. Okay, there's two things I could do. One is I could cut and paste them into an editor, but that's very inelegant. What you can do into in Unix, and it's really a very powerful tool, is you can redirect the output. So the right arrow means redirect the output. Instead of printing to the screen, that will redirect it to a file. Okay. And at the moment, all that means is I can now count word counts.txt. Okay, that's useful. But the redirect is very, very important. That basically, instead of by default, commands will output to the screen, but you can redirect. We can redirect to a file. Okay. Okay. So okay. So what I could do now is I could do. I could create a directory called mcdir my directory. Whoops. And I could do WC star -L star, for example. And you'll see you'll see that you get an error. My directory is a directory. Okay. If I redirect that output to word counts.txt, you'll see I still see that text there. I still see this error message. So actually, Unix systems have two output streams. One is called standard out, which is print statements. The other is standard error, which are error messages, and they're separate. So what this redirect does is it redirects the standard output to word counts.txt, but not the error messages. Okay. So if I do that, I will see error messages on the screen. Okay. So that is, that's, a slightly weird thing, but that's the way it works. If I want to get all the output, I do a very, very strange syntax, which says redirect everything. And now I see if I word counts.txt, I have the error in there. There it is. So these things, it is one of the unfortunate things about Unix is that, commands and, well, symbols are massively overloaded. That is not a very user-friendly or helpful syntax, but that's what it is. Okay. So the standard way of saving output is to do redirect with the output to the right. But if you want all the screen output, which is not just the standard output but the standard error, you need to do something else. You need to do this funny syntax and there, which I think is a very weird syntax, but that's very, very strange. Okay. You may not want to actually, you might want to append. Okay. So if I do, let's have a look. If I star.fastq. I do cat word counts.text. I see that. I might want to do all the .tar files. Oh, let's do the gene association one. Okay. That has now overwritten the file. So the redirect operator, the greater than, overwrites the file if it's already there. If you want to append, okay, you have to do, let's recreate it. But now, if I want to, you do double arrow, and that appends to the end. If I now cat word counts.text, you'll see that at the end, I have this extra line for gene association. So the basic points is that redirect to the right creates a file. The double arrow, 2 chevrons, appends to the end of it. And actually, if there isn't a file there, it will create. If I remove word counts.text and do the same thing again, it will now just be the same as if I'd done a. So the double arrow appends to a file if it's there, but also creates it if it's not there, which is probably what you wanted. Okay. So what you could do is you could basically, you might find that you're going to end up creating lots and lots of temporary files. You're going to have scratch.txt and scratch.out and things to be able to chain these things together. What you can do in Unix, which is very powerful, is chain things together with piping. Okay, so just before I go on to that, which I think is the last, really the last section in this. I went through that rather quickly, to apologize for that. But did anyone have any questions about that? So wildcarding, star matches a whole bunch of stuff, so if I do ls-l star.fastq, it will basically apply the ls command to all the files that end in fastq. Okay. The other one, which is also useful, is imagine I wanted to list all the files with 3-letter file extensions. Does anyone know how to do that? So I want to list all the files that have 3-letter file extensions. So star.star lists all the files which are something.something, but that's not what I wanted to do. I only wanted to list files which end with a 3-letter file extension. No, so that's that. So no, so star matches multiple characters, so that's important. So yes, star you'd think would work, but it doesn't. Star still lists everything. Okay. So there's another file. You can't do it with star. Okay. So the other one that I like is question mark. That matches a single character. So I find that very useful. Star.question mark will list all the files that begin with something, then have a dot, and then end in 3 characters. Or let's do all the 2-character files, okay? Or all the 1-character files, and there aren't any. So I think, there is a whole, zoo of regular expressions, which these are generally called, which expand to match files. But to be honest, with a combination of star and question mark, and I think question mark is very, very powerful, you can basically do almost all you want. So I think question mark is a very, very useful one to know about. I find it very useful as well. Okay, so the other thing you might want to do is, imagine we want to find out how many files there are called fastq. Okay, so let's do ls star.fastq. Okay. Let's redirect that to a file .list.log, okay? And let's see how many lines are in fastq.log. Whoops. There's 16, so there's 16 files. If you look at that, that's a bit weird, okay? So there are 16 files here, right? But when I did star.fastq, how many lines were there in that output? ls star.fast. I'm telling you, to count the number of files, you do an ls and then you do a word count of how many lines there are in that file. But when I did this, how many lines are there in that screen output? 4. So why do I get the right answer? It's funny because I hadn't really thought about these things for a while until I was going through the lesson the other day, and I thought these things are a bit weird. Anyone know what's going on? Yes, there's a character in. So in fact, yeah, if I cat fastq.log, it's like that. And the point is that ls, if it's outputting to the screen, to the terminal, formats it, okay? And in fact, you'll see that it tries to do clever format. If I do ls star.fastq, okay, it's done a 4-column formatting. If my window was narrower, okay, it would do a 2-column, okay? So the ls format based on the output. However, if it's redirected to a file, okay, what did I call it? Word? Oh, no, I didn't call it. I called it was it fastq.log? I can't remember what I did. Yep. It basically so David's redirected to a file, so I won't put any of the pretty formatting in. So actually, it's not immediately obvious. However, you're going to see that my direction is going to be silted up here with lots of silly fastq.log commands. And actually, you can get rid of that by using the pipe command. So what this says is it lists all the files called with fastq and takes the output of that and puts it into the input of wc-l. And this is probably the most powerful thing in Unix, is piping things together. There is a hidden intermediate file that you don't see, obviously, but this allows you to do these things, and that gives me, says there's 16 lines. So you do end up doing this thing quite a lot, that you basically end up chaining together commands, and the pipe command is a way of taking the output of one command and piping and putting it into the input of another. Okay, so what this is saying is, just to dissect this, the shell expands star.fastq into ls minus 1. Okay, yes, so ls, you can do ls minus 1. Okay, fine. I'll come back to that. So there are commands to do width, but what this does is this is expanded into all the files, then they're listed, and the output is put in the input of the double word count program. So that does what we want. Okay. If I want to list by when I do this, okay, because you're fooling the ls command, you're not redirecting it to the screen. It's not going to the screen, it's going to another command, so it's unformatted. But cat just basically copies its input to its output. So that, although cat copies its input to its output, ls_star.fastq piped to cat is different from ls_star.fastq, because the ls has different behavior depending on whether the output is going to the screen or another command. So that was just an interesting kind of trick. Okay. So that is sort of, I've gone through that rather quickly, but I think that I'll go to the to share the sorry, my brain is not keeping up with my mouse today. So there is more information here. I've kind of gone through it quite quickly, but the key points are: the star wildcard is used to placeholder to match any text that follows a pattern, and I think that also equally useful is the question mark operator or character, sorry, that matches just a single character. I find that very, very useful. You can redirect a command's output to a file with greater than, okay, or you can command can be chained with pipe, okay. And in fact, also you can redirect the input. Okay, so for example, there are more than one way to skin a cat. If I share the okay, so we have I think we had fastq.log, okay, which had these files in it. Okay. I can basically I could do If I type word count on its own, it actually reads from the terminal, hello, goodbye, and it says there were 2 lines. I can say don't read from the terminal, but take the input from fastq.log, and that does 16. That's the same thing as saying actually wc minus l on fastq.log, or cat fastq.log piped into wc minus l. All those are sort of equivalent. So this allows you to basically chain commands together to build up more complicated things. Okay, so the one thing I didn't cover here, because I went a bit too fast, and probably one of the most important commands there is grep. So grep stands for grep, get regular expression. Grep is really useful. So for example, we'll see that there's this there's a file here called dmail all r6.gtf, and it is hugely long. Okay, this is some genetic database. Okay, how long is it? It's 74 megabytes. Let's actually just star RTF because I can't be bothered typing this in. It is GTF, sorry. That's not a very, okay. It's 500,000 lines. Okay, so yes, cat file pipe, although actually you can just do more file. So yes, you're absolutely right. So cat piped into less or more is exactly the same as less dmail all. Are the same thing. Grep is very, very so we're looking for, there was a particular line in this thing which begins ACT. So I want to look for all occurrences of the string ACT5C in that file. Well, grep says on a line by line basis, print out all the occurrences of ACT5C, and there we can see there's lots of them. How many of them are there? Well, I can pipe the output of that into WC minus L, and I know there are 46 occurrences of that. And so actually, grep is incredibly powerful tool to get, to extract lines of files from, to extract data. So typically, the sort of modus operandi in Unix programming is, and it's a bit lazy, but it's the way I work. You dump lots of, when you want to output data, you dump lots of stuff to a file, and you worry about disentangling it later on. So you use post-processing tools like grep to pull out the bits that you want. You should probably do it a bit more elegantly than that, but it does mean that you don't have to worry so much when you write output from a program, as long as there's some differentiating string, some unique string on each line. Now this is on a line-by-line basis. Then you can get the output from these files later on. Okay, so that's sort of so it was a bit of a run through. But was there any questions about that? Any things that that people wanted to ask before I go on to the programming, which is probably the most involved part we'll do next. And some things are a bit weird. For example, star doesn't expand to all the files. It ignores the. So if I go CD, okay. If I do ls dot star, that actually is a bit weird because it lists all the dot files. It lists dot, which is the current directory, and it lists the directory above, which gives me all the people who have. So it is a bit. It's a bit of a strange thing. But if you want to see the hidden file, you probably do dot. So when you type a command, okay, it reads input from the standard input, which is the keyboard. So if I type, is WC a good one? If I type grep, yeah, that's right. If I type grep hello, okay, it's looking for hello. So every time I type hello, actually it's hard to see. Okay, I see it twice because it's pulling that out of the stream. So any Unix command that you type will take its input from the keyboard, which is called standard input. However, you might want a file that you wanted it to read from, and you can do that in two different ways. Okay, well, lots of different ways. But for example, if I wanted, where do I have a file here? It was in bash lesson, wasn't it, where I had my stuff? So let's look at this dmail all.gtf, right? I'm looking for these ACT5s. I can do grep ACT, what was it? 5C on that file. And that, sorry, it's case sensitive, so, okay. And I get 46. If I typed just grep, okay, it would actually read from the standard. I can tell it to take your input from this. So it's saying don't read from, in fact, you tend not to use it that much. You tend to actually, what you would normally do is you would normally do this. You would normally pipe it into. So the redirecting the standard input isn't something that was done quite so much, because you can normally do it with pipes. But if the thing you want to use as standard input is already in a file, you can redirect. Instead of reading data from the keyboard, it reads it from that file. So the data in the file replaces the keyboard. Does that make sense? It's maybe worth, yeah, fine, okay. That's let's go. I'll share the correct screen again. Share. So we were due to take a quick break at 2:15 and start the final thing, which is probably the most involved part, which is about shell programming, at 2:30. But unless anyone had any questions, I think maybe the best thing to do would be to take the break now, if that's okay, and come back in 15 minutes at 20 past to give us more time for what is definitely the most involved session, which is the programming and looping and things. Is that okay with everyone? Okay, so I will now. Hello? Okay, so I'll maybe go through for a few more minutes if people want to start. Juan pointed out that we already had some slack in the timetable. Wasn't slack. We had a buffer space at the end from 3:30 till 4. So so there was already some slack built in. So I'll maybe just wait a few minutes, because I guess that didn't turn out to be very much of a long break. But just to say, we of course will be doing this while you're doing the script variables and loops, and that's the material that we'll be covering. It's difficult for me to simultaneously share. What I'd like to do is to have that material up on the screen. Obviously, you can see it because it's on the web, but I'd like to have it up there as well. Share my terminal. That would mean sharing my entire screen. The problem is, if I share my entire screen, I can't see the chat. So the compromise is I'm just going to share my terminal, and so hopefully you'll be following this online, with the material there. So that's slightly awkward, but I think I'd rather be able to see the chat. As I said, given this is going to be quite an involved session, it's quite technical. Please, chat at any time you have an issue. Also, it's just been pointed out to me that by Juan and Julian, that if you click on the icon, which for you is just unfortunately a head and shoulders, if you click on the icon in the bottom there, you can set your status to be sad, confused, slower, surprised. I'll make myself happy, and you should be able to see that that I'm happy. Okay, fine. So that allows you to do various things I've cleared the status there. But in fact, you know, faster, slower. I mean, please use the chat if you want. But if there was something which you were confused on, then you can look at that. It's a bit difficult for me because I think that if I see the chat, let's think. What do I see? Yeah, it's not immediately obvious to me. I can't simultaneously see the chat. Yeah, I can't simultaneously see the chat and the attendees, but I do see. I'll probably look at the attendees, and then I do get a notification if there is a chat message, so that should work okay. Okay, we are still. I'm just checking that I haven't missed anything. Yeah. So I will now start sharing. So this is the material we're going to be covering. It's supposed to take about an hour, but I'll maybe. Okay, so thanks, Juan. So I can keep an eye on the chat, and Juan can look at the participant list. I'm going to go through this, and I think this is the first time I've taught the entirety of this lesson in a one-hour, and I think that the initial sessions are quite generous in their time, which is why I've been able to make up time on the schedule despite the teething issue with Archer access. But I think this is actually, you know, this is actually quite a bit tight on time. So hopefully, so I will now share my content. Check I got the right one. Okay. So what we're going to talk about is one of the things which surprised me when I first started using Unix. I'd been used to using a microcomputer. This is way back when. This is in the mid 80s when people had things like ZX Spectrums, and I had a BBC Micro and such like. Is that on an old-fashioned computer, there were programs which were installed on the computer, commands that you could run like ls or editors, and that was it. Okay, but one of the powerful things about Unix is that all programs are just programs. If you create a program, the only thing which is special about commands like ls or cat or more is that they are pre-installed. They're just programs that are pre-installed. If you write your own program, and we'll see here how to write simple programs which are called shell scripts, they become just like commands which there's no difference to them than the ones that are centrally installed. Okay, there's nothing magic about the centrally installed commands other than they're centrally installed. And that's one of the power of Unix systems, is that any user can write their own commands to automate things that they do all the time. Okay. And so what we're going to do is we're going to learn how to turn a set of commands into a program. So if we want to, if there's 3 commands we run a lot in a row, we don't want to keep running them in a row. Computers are supposed to make our life easier. They're supposed to automate things. And we'll see that these simple shell scripts are a very, very easy way of doing that. How to write a shell script, how to understand and manipulate Unix permissions. File permissions are important to understand. Understand shell variables and how to use them, and write simple loops. And actually, at the end of this lesson, you'll be able to write, you know, really quite complicated, hopefully quite complicated scripts that do sensible things and make your workflows easier. Okay, so you'll see to write. Let's write a script. Now I'm going to use an editor called Emacs. That's the one I'm familiar with. Apologies for that, but hopefully it's just a text editor. NW stands for don't open up a new window, but we're going to have something called demo.sh. So if you see we want to do something called demo.sh, again, .sh is a convention. Okay, it's a shell, so this is a shell script. Okay, now all a shell script is basically, instead of typing in commands one by one, it's just a list of all the commands. So if you want to type in more than one command, you put them into a file and then you execute it later, and that allows you to execute all the commands. But there's a few interesting things. First of all, people mentioned earlier on that there are actually multiple shells, okay, and they have slightly different quirks and features. So how are we going to tell our shell that when I run this demo.sh, I want to run bash? Well, there's a magic command, which is this. You put at the first line, which says, this is a shell script. Someone asked a question there and I've gone to the wrong place. So if that's what to do Emacs and Nano other than the colors, nothing. So it's very important to note that how you create a file is irrelevant in Unix because it's just a simple text file. That's one, you know, people have editor wars and have their, basically, I cannot tell if you give me a text file which editor it's being created in. Okay, it's just a bunch of text. So that's why it's horses for courses. I happen to use Emacs, and the reason I'm using it here, it's going slightly off piste, is I'll make fewer errors by doing it than if you did. Some people will use Vim. Okay. Okay, it's not Vim and yeah, I think Vim and I'm not supposed to express opinions in this course, but yes, my personal opinion is Vim and VI are a nightmare to use, despite the fact VI was the first full screen editor I ever used. So they are, but they're means to an end. In fact, if you're a real, well, I'll come back to that. Okay, so that is just, we'll come back to this a bit tomorrow, but that is just, think of it for the moment, that's just a bit of magic saying, this is a shell script which I want you to run through the bash program. Okay, that's fine. Okay. And then echo is a command which just prints its output to the screen. So basically, I just do echo R script worked, and basically that I can now save it and quit it. Okay. So I now, if I can't demo.sh, okay, then there's the script. That's what I want to do. I can now try and run it. So I do demo.sh, and it says permission denied. Okay, so that's interesting here. So it's the setup. Okay, that's interesting. Fine. Now what the instructions show is that demo.sh is command not found. Now, so what's happened is that this the lesson was written for the, apology, we had to switch system at the last second. It was written for another system. Now, when you type a command in Unix, Wibble, okay, the system goes and tries to find it, okay? Command not found, Wibble, okay? There is no command called Wibble. But what it has is it has a default, well, it has a search path. It goes and looks for that command in a variety of locations, okay? And the question is, does it look in your current directory? Okay. Now on this system, on Archer, it is looking in my current directory. When I do demo.sh, it finds it in dot. Okay. On a lot of systems, dot is not in the search path. Okay. And so that is no. So there is a problem about chmod. Okay. So the error message there is exactly what Luciana is saying, that this is not executable. But when I typed demo.sh, it found it and said this is an executable. If you look at the notes on the web, it says it should say command not found. Okay. And that's a difference in this system from the system which we developed the course on. But on Archer, dot, the current directory is in your search path. Okay. It finds it. So apologies, there's a difference here between what I'm showing you and what's in the notes. And I didn't spot this beforehand. Okay. So does that make sense? Okay. So so you're right, that particular error message is because the permission is denied, and that's because if I do an ls f, we'll see that demo.sh is just a normal file. Okay. Now to make things, or we can use ls-l. Okay. And basically, if you look at the web page, you'll see, well, ls-l gives us a huge amount of information. But the first thing here tells you whether it's a directory or not. So D, in fact, it would be nicer actually if I did ls-lf. There we go. Fine. So you can see that bash lesson is a directory. How did it know it's a directory? Well, it has the permissions field of D. Okay, so that says it's a directory. Okay. If there's nothing there, like draft.txt, it's not a directory. So a D, when you do ls-l, you get this these status bits here at the start, okay? And this is, you know, these are the permissions. And the permissions are split up into three sets for three. There's user, which is what you can do, okay? There's group, which what people in your group can do, and there's other at the end. Now this, sorry, user, group, and other, okay? So there are three fields, and this shows that me as a user, I can read this file, I can write this file, I can execute this file. Other people can read and execute it. Now the S here is, it's something of a, the file permissions be extended much, and this is called a sticky bit, and it's slightly weird. It's a particular way of changing the way the default behavior works. So I would, for the moment, ignore. I know it's confusing, but I would basically, okay, so how does it know who's in the group? So that's very, very useful. But so I'll come back to that, Matt. That's a very good question. But let's look at a normal file, okay? Fuzzy dot. Let's have a look at a normal file, like for example, demo.sh, okay? It's not a directory, and it's not executable, right? Executable means it's an executable file. It's a program, and for slightly strange reasons, directories are executable, but that's a different question. So the reason I couldn't run demo.sh is it wasn't executable, but I can read and write it. People in my group can read it, and other people can read it as well. So obviously I'm only allowed to write it, but other people can read it. So groups, if you do groups TCO11DSH, that shows you all the groups I belong to. And I belong to the TCO11 group, the Arch users group, and the Arch login group. But the group which is relevant here is TCO11. So what this is saying is demo.sh, let's look at that. Demo.sh is owned by me, but its group is TCO11. And so people in that group follow this second set of permissions, and they can read it, not write it, and they can't execute it. So this is who owns the file. So this tells you, this says who does the first three settings apply to, the first three letters. This tells you that the next three apply to everyone in group TCO11, and this is to everybody. So there's no user group other or user group in all, okay? So that's a bit, it's all a very, very terse, and it's too terse. Unix permissions are not flexible enough. In my opinion, they're not fit for purpose, actually. But anyway, but Unix, you know, was defined in the early 70s, and we've, you know, haven't changed it much there. So, but the reason that this file is not executable by anybody. So does that make sense? It's slightly confusing, but if you look at the notes, it goes user permission, is it a directory or not? User permissions, read, write, execute. Group permissions, read, write, execute, which is that group. I can actually change the group. I could do chgroup. Let's do it on draft.txt and change it to be, see, I'm a member of three groups, TCO11, Archer users and Archer login. Never heard of them, but let's do it. So, okay, the other way around. So I have to do chgroup Arch users. It's that way around. Draft. I should look at the man page. You'll now see it belongs to Arch users. So it has the same permissions, but these read these attributes now apply to people in Archer users, not in TCO11. We're all in TCO11. Okay, so on if I'll maybe just well, I'm going to edit the, so what in Control X, that's correct. Control X. Okay. So what I have to do is, so the fourth column is the size of the file, okay, the length here. This is the last time modified, not accessed, but modified. And this is the name of the file. So ls-l tells you almost everything there is about the file. This sticky bit is because we have quite a strict group hierarchy in Archer. And so we try and mandate default permissions for files. And that sticky bit is a kind of persistent bit, which will mean that the files will have the correct group permissions for them. Now, I don't want to go into the details of it much because it's slightly fuzzy to me how they work. But on a normal system, it's for directories. Apologies. Directories have this kind of persistence of what the permissions is, which is a bit complicated. But on normal files, it's very clear. Okay. So who is logged on to on Archer? Because someone tell me someone who's logged into Archer. Okay. Okay, Matt. So Lucia. So if you're in your home directory, could you type cat /tco11dsh / demo.sh. Okay. So could some you type do cat /tco11dsh / demo.sh from your home directory? What do you see? Okay, so Emacs is Control G in Emacs is often the way to get out if you're stuck. So what did people get when they typed that cat /tco11dsh / demo.sh on Archer? What did if you type in your home directory? Permission denied, exactly. You're not allowed to read that file, okay? Okay. But if I make it group readable, so how do we change them? Well, there's a file called chmod. Apologies. There's a program called chmod, a command. So chmod G+R says add group read permission to demo.sh. Okay. So now, can someone try and Anastasia do the same thing again? Can you now do that? Do you see the file now? Oh, permission denied. Okay, the reason the permission is denied is because you can't, sorry, you were always able to read it. It's because you can't access my directory. Sorry, okay, so this isn't going to work. We have very strict directory permissions. Sorry, no, it doesn't exist. So I've jumped ahead of myself here. This is my fault for not going through this entire thing step by step. But if you do ls -l ... you will see that all these directories do exist. Yeah, there am I. Okay, and Luciana, I don't know what your login name is, but you will see that the group you don't have. It's a bit weird here, but you do not have read permission to my directory. Okay, so yeah, exactly, cannot open directory. So this is going to be a bit weird. What I should do is I will copy demo.sh to shared. Okay, which is another directory which is for shared, and I will for the moment. So can you do cat /shared / demo.sh? I don't understand what you're saying, Luciana. So yes, so Luciana, I didn't understand what your comment was there. Apologies. You are not one of them. What are you typing, Luciana? What? Okay. So it seems to work. Okay. Now I can do chmod -r. Okay. That says remove read permission. Now try and cat it. Are you able to cat it? So you're able to see it now. So now permission denied. But what I could do is I could do chmod G+R. Okay, and now can you do it? Can people see it now? Yes. Okay, but what can I do with this? Yeah, okay, so I could also have given world's read permission. So that's the way that you can that you can kind of change permissions. But the thing we actually want to do here is make it executable. So we want to do chmod plus x demo.sh. That makes it executable. So if I now do ls minus l f. Oh, so Luciana, you need to type. Okay, no, okay. So Luciana, you've logged in as you've logged in not as a course account, but as your own account. So the group, you'll be in a different group, and that's why you're not in the training group. You're in your own N02 group. You must have a pre-existing account, so that's why you're not seeing what I'd expect. Yeah, okay, fine. If I ls minus lf demo.sh, you'll see that two things have happened. First of all, it's executable, read write executable to everybody. Also, we've got the star at the end, which says that's the minus f decorating it, showing it's executable. Okay, so if I do ls minus lf on everything, we'll see that demo.sh is now. So I will do /demo.sh, and it says our script worked. Okay, so Unix permissions are slightly contorted. Basically, I mean, as I said, Unix was invented back in the 70s. I don't know exact date, but 72. And they tried to squeeze all the access permissions into a few bits as possible. So they restricted it to read, write, execute for 3 groups, user group and other, and every file has to belong to a single group. That is not very flexible. It's really not a very, and so there have been various extensions and things, but that's the way it works. That's the way it is. You would not do it like that now if you were designing an operating system nowadays. You would not have this very limited set of user group and other access permissions. You would have a list of groups who could access a file. That's one of the big weaknesses of Unix, in my opinion, that you can't list multiple groups to access. In fact, there are extensions called access lists, which modern Unix systems have. But by default, the access permissions are they're not nearly as sophisticated as Windows. Windows has a very sophisticated, you can right click and add people. In Unix, by default, a file belongs to a particular group, and you have to add people to that group to give them access. So I don't know how Macs work, presumably they're Unix-like. Windows actually has a much more sophisticated access system, which is more flexible. But that's history for you. Okay, so still second. So I would just kill it. Can you just? I mean, I would. I would open up another window or just kill the whole thing. Mat. Emacs can get slightly weird. Yeah, there's a whole. I mean, the problem is. Control Q is another one, because Control S is actually stop in Unix. So that can Control S. So Control Q can sometimes help. But yes, Emacs does get stuck sometimes. Yeah, I mean, I think I would use if you use whatever you're happy with. Okay. The interesting point about hash is a comment. Okay. But this is a special comment, okay? So basically, this is a special comment. Things beginning with hash are comments, but that is a special comment. This exclamation mark, sorry, hash banger, what you want to call it, hash exclamation mark is a special comment, which is actually saying, look, I want you to run this hash bin / bash. I want you to run this demo.sh through bin bash, okay? And that's a trick which we'll see used again tomorrow. You hide special commands in comments. It's a bit, well, that's the way it's done, okay? Okay, so that's not particularly useful, okay? But I now have demo.sh, which, yeah. Yes, the hash. That's right. It has to be right at the start. Otherwise, it doesn't work. So, I mean, one of the most important things about any kind of programming is that you want to be able to manipulate variables. And in Unix, there are these things called shell variables, which are part of the shell. Okay, and so by convention they have capital letters. So we do. Yeah, if I do var, this is our variable. It sets a variable var to be that string. They're just strings. And to print it, echo. If I do echo var, I get what I said. I get var. Okay, but so that's just taken as text. If you want to treat it like a variable, you have to put a dollar in front. You have to say echo the value of the variable called var. Okay, so it's slightly weird. When you define a variable, you say var equals. Okay, but when you want to look up its value, you have to put a dollar in front. That's not what you'd expect from programming in Python or C if you've done programming in programming languages. But in the shell, I mean, in scripted languages tend to have this differentiation. Okay. Also, okay, it's very important to realize that in Unix, by convention, a space separates commands. So the reason I had to put quotes around there is if I did var equals this is our variable, okay? Okay. What it actually did is var equals this, and then thought I wanted to do something. This. So okay. So Luciana, where is the variable saved and for how long? Well, it's saved in our shell. So in fact, if we type set, we can see all the variables which are saved in our shell. And in fact, you'll see there are huge numbers of them. So how can I find out what the value of? How would I find out? So that's, you know, how many lines were there? 4,000. So there's more than 4,000 lines of state in your default shell, which is madness. How would I find out what the value of var was? By using set. Set tells me the value of all the variables in the shell. How could I find out what var is? So the variable is saved in the shell. So when I log out, it will disappear. Okay. But can anyone? How am I going to? So set prints out the value of all the variables, but I only want to know what var is. Yes, set piped into grep var. And in fact, there's a lot, but there is var equals this is our variable. Oh, so it actually failed before. Okay, it didn't do anything because it failed. Okay, okay, fine. So so it lasts for the life of the shell. Okay, so if I do echo $var, this is our variable. So if I create another cell and I type bash, yeah. Now I go slightly beyond the. I'm actually in a different shell here. You can't really see. Let's go back out again. You didn't really see that. So let's go somewhere. Let's cd to DocuSoap. Yeah. Okay. Okay. If I type bash, I create another. Oh, I stay in the same. Okay. I'm in a different shell. How can I tell? If I do echo $var, it's not set. And if I exit, I drop back. If I type exit again, I'll log the SSH. So you can create shells within shells. So the variable is part of the shell and it lasts for the lifetime of the shell, but it's not by default propagated. Okay. If you want to propagate it, instead of doing var equals this is, oops. I have to do export var equals this, and that gives it greater permanency. Okay, that says not only define it in this shell, but define it in subsequent shells. And I hope this works because I'm kind of going off piste here. Oops, I type there. Okay, yeah. So, well, okay, let's have a look. Okay, sorry, I'm going to go back to. So apologies, I've got. I have to kill. Okay. Okay. So, what do you? Okay, let's do. I'll do unset, right? Unset var. Okay. Var equals. I'm going to do. I'll give it a cut and paste. Okay. What happens, do you think, when I run demo.show? So these are very, very good questions, and I hadn't thought about them before. But what do you think happens when I run demo.show? var doesn't have a value because demo.show is run in a subshell. So scripts are run in shells. So you might not want to have shells within shells, but that's what you get. Does that make sense? Okay. So you're right. Why would you want to have a shell within? You might not want to, but when you run a command, a shell script, that is run within another shell. So it actually spawns a new shell to run that thing and then comes back in again. So by default, the variables aren't exported. So this is the question: do you want this variable to propagate to shell scripts? And if you do export var equals this variable, and you do /demo.show, then it's defined. Okay, so does that? So these things aren't, they're slightly complicated, but it is. So it's the question is, do you want that variable to be exported to subshells? And subshells include all scripts that you run, because when you run a script, how long does that persist? Until I log out of that shell. Yeah. If you use bash demo.show, it works as exporting, because that, does it work? Does it work? That's interesting. So that was actually a question which occurred to me, and I didn't mention it because I didn't know the answer, but let's have a go. So it does work. So it must be a technicality between whether it's a subshell or a. That doesn't work. No, that didn't work. This doesn't make any sense. I've got myself very confused here. So that's that. Okay. So that's what I expect. Yeah. Var equals this is our variable bash echo $var exit. So if we do bash /demo.show, yeah, it's not. So sorry. So I was getting confused. So actually, so the statement, if you use bash demo show it works for exporting, is not true. I think it's basically. I think when you type export var equals whatever, that marks var as an export variable. Yeah. So when I do var equals this is our variable, if it would previously be defined as exported, it remembers it was exported. Does that make sense? I think that's why we got the behavior I didn't understand. So Anastasia, it's not true that bash demo is so I'm actually doing what I should do is export var, yeah, var equals this is our variable. Yeah, that's what I was really doing, and now it's exported. Yeah. Unset var unsets the value of var. Okay, it says it's no longer set. It's the only way to unset it. It's not the same as saying var equals, yeah, because then it has a value. Well, it's the same. Now, someone asked a very interesting question, Luciana, is single and double quotes. So this is all getting a bit of a, but if I do, let's do, yeah, okay. New var equals $var, okay? What do you think this is going to give me? Anyone have a guess? Well, this is our variable. That may be what you meant, so that's interesting. Okay, that okay. What do you think that's going to give me? So I want to. Could you tell me? So you're right, Marcy. It's like I want to know what the actual text which will appear on the screen. Okay. Yeah. So it will be okay. So I'm trying to answer Luciana's question here. Yes. It still works. Okay. So quotes. Quotes mean past this variable. So within double quotes, yeah, then the variables are expanded, okay? But this is different, yeah? So the question Luciana had was, are single quotes and double quotes interchangeable? No, they're not. So it's not like Fortran or, okay? If I do that, it says $var. So double quotes say, set this value, but expand the variables. Single quotes are hard quotes. They're saying just treat this as text, and this is where things can get very complicated, and it does do your head in sometimes. But that is the basic point: is that double quotes, things inside double quotes will be expanded. Okay, things inside single quotes will not be expanded. It says just treat this as text. Did that answer your question, Luciana? It's a good question. It's something which still catches me out a lot. Okay, so so we've basically done okay. So what we want to say, file equals dmail all dash r. What is it? I'm going to cut and paste this. I'm going to cheat because I can't type. Okay. Okay, so Manasseh's done a very good thing. Well, so I'll answer that. It's a very, very good question. So that is a very, can I just finish this? I'm in the middle of it. That is an extremely good question. Okay. Oops. Oh, I need to be, I think I called it bash lessons, didn't I? Yes. So I'm going to have to work it. I'm going to have a copy. So right. So number of lines in file is that. That's not very useful because that is not. That's just counting the words in one file. But the nice thing about this is that there are predefined variables like $1, and that will then, that says the first argument, okay? So you can do, and then I can do count itself, the number of lines in files. It will base, so within a script, $1 is the first argument, okay? So that is why it's useful. I've now written something which counts the lines and it takes a command line argument, okay? So to go back to Manasseh, if I wanted to do, if I do var equals, let's do var equals Fred, okay? What were you asking there? Why the dot? So if I do new var equals $Fred 22, right? It complains, okay? What I wanted Sorry, idiot. Sorry, this is, sorry. So I've just done the, sorry. So I'm going to unset var, unset new var, and I'm going to go back to this again. So apologies about that. Right, so we want to do var equals Fred, yeah? New var equals $Fred 22 $var. That's fine. Sorry, $var. It doesn't like it, yeah? But if I want to do that, sorry, apologies for my typing. I get Fred 22. So this line, yeah, says new var equals $var, and then the command called 22, which doesn't exist. This says set new var to be everything within the double quotes, expand the $var and the 22. So does that, and it's exactly what Luciana said there. Sorry, she said the same thing. So does that, Manassi, does that explain the difference between them? It is, I mean, it is subtle. It does get quite confusing, but hopefully that explains the difference. Yeah, okay. So what we really would want to do is to, we might want to, so what we'd like is a nice thing is to do, imagine we wanted to have a variable set to a list of files, okay? So I want to have a variable called file list, yeah? Yeah. So let's do file list equals ls minus l. Well, we've shown that doesn't work, okay, fine. Let's do that. It's set to the string ls minus l, but I wanted to see the output of the command ls minus l. And the way to do that is there's a special syntax, which is again very weird, but it is this. That says set file list to the output of ls minus l. Yeah. And that, oops, sorry, I can't type, can I? I'm really sorry, it's echo. Then that gives me, and again, it's formatted it differently because it hasn't put the carriage returns in, but this allows you to do things like loop through all these things. Okay. So basically, I mean, I think that's really so I think that's very interesting. So var equals ls minus l doesn't work because it says var equals ls and then it tries to do minus l. Var equals ls minus l works, okay? And within double quotes, I can expand variables. But if I did single quotes, it wouldn't expand the variables. But if I want var to be actually the output of a command, I do that. Oh, sorry, I'm really sorry about my typing. Yeah. So those things are really, now, so that's all just set up. The main thing is what we're going to go on to next is loops. That's really the thing which is useful, okay? So I was basically going to, that's been about 3/4 of an hour. Can we just, I'm getting a bit parched here. Can we just take, well, are there any questions? Apologies. Are there any questions at the moment? I just want to take a 10-minute break before we do the final session because I wanted to, so it's not, you know, it's not trivial. And I would not say the syntax is self-explanatory. It's you know, it's very terse. You know, it's not clear. It's not immediately obvious what single and double quotes do. This dollar syntax is a bit weird, but once you get used to it, it does allow you to do really, really, really useful things. Okay. So one thing I should maybe have said is if I look at my demo.show, okay, it did number of lines in file is that, yeah. If I do /demo.show without anything, it basically, there's no dollar file, so it doesn't work, okay? What's useful is there's a magic variable called $hash, okay? So when I run /demo.show, there's 0 arguments. If I do it hello, goodbye, and wibble, it says the number of arguments to this guy's 3, okay? So the command's failed because I've basically there's no such files actually, but things like that, $hash, there's this magic number which tells you how many commands. So if you're going to write your own programs which take command line arguments, you would check the value of that variable. I haven't told you how to test yet, but you would check the value of that variable, and you would then be able to say, okay, you've not called it correctly, you've not passed the right number of arguments. So there are these things. Often looking at other people's examples is a good way of learning, because the syntax is very baroque and only really makes sense when you see it in context. But people didn't have any questions. I'm happy to answer any, but if there aren't any questions, I would just like to take a slightly unscheduled but a 10-minute break just to get myself a glass of wine. Sleep. So I promise it's going to be a glass of water, not a glass of wine. We will come back at 20 past, and I'll just do the last bit, which allows us to write actual real scripts. Is that okay? Yep. Okay. So I'll put up a little. But just for the, does anyone have any questions at the moment about Archer in particular, or about the course, or what we're going to do tomorrow, or anything at all? I just want to give people 3 or 4 minutes just to get back, because it wasn't much of a break. I heard a beep there, but didn't see anything. Okay. Fine. Okay. What's working, Luciana? Just to check. Sorry, just to say the mic. Fine. Does Archer have silk? What's silk? I didn't quite. I'll have to Google it unless you explain that to me. Oh, this silk. This, as used by the Met Office. I guess that's maybe where you're. Okay, is that what you meant? So we'll yeah. So we will cover this all tomorrow, but just to show you what the power of what we'll see. We'll cover all this tomorrow about how to find out what else. So I'll share the right screen. Give me a second. So yes, so there's module. Well, first of all, if I type silk, it's not there, but module avail tells you all the software that's available on Archer. Okay. Now you'll see there's way too much stuff there. Okay. So we could try and let's redirect to a file. Okay. Now nothing happened. That's because this module avail command is really, really annoying, and it prints its output to standard error. So we have to do and now we can grep for CYLC. Is that the right? So the reason the module avail pipe grep still didn't work is because there's this annoyance that module avail redirects to standard error, and I don't think it's there. So I don't think it's there. But that was it's very annoying that that we don't have it. Okay. So what I wanted to do was show you how to do loops in the shell. That's really the most important thing. And the basic syntax is, okay, let's call it what we're supposed to do. It's called loop.show. Okay. Standard thing, it's a bash script. And now indentation is up to you. It's very unusual in programming for indentation to be significant. Of course, it is in Python, but we can. But anyway, so that is the way that loops work in the shell. It's for var in list do commands done. I always get it wrong, but that is the way. That in itself isn't particularly useful, okay? But if we run that, we do chmod plus x loop.show, and we run it, we get first, second, third, okay? Now, what I wanted to do was I wanted to write, there's examples on the web here, but I wanted to write a script to find out everybody on this course who's on the same login node as me, okay? So the two things we need to know are, okay, there's a command called who, which tells everybody who is on this log. Now, some of you are on different login nodes, okay? I'm on login node 004 here. Some of you won't be on login 004. Well, if we type who, we can see that there's Luciana and there's Ryan Wood. So at least two of you from the course are on the same login node as me, and there's me here. I'm logged in from a BT hub, okay? Okay, so that's useful. But I want to loop over everybody on the course, yeah, and find out if they're there. So for example, I could do grep Ryan Wood who pipes into grep Ryan Wood, would show Ryan Wood is there, but I should pick somebody else who is on the course. I don't, can someone give me their login name? I don't have it because the login names you picked yourself. Someone type their login name here just to see. Bash 75. You're not on that loop, okay? So, but I want to loop over all the people, okay? Is 1928 my IP? I guess it is. Yes, I guess it is. Yeah, are you at an institution? Are you not? Are you at home? Or maybe you're coming through a VPN. That looks like it's a. I don't really understand networking, I have to say. Home in the UK without, you must have a stat. Yeah, well, maybe that's. Oh, yeah, well, BT does something weird, obviously. So what I want to do is people.show, let's call it, yeah. So the way I can do it is I can do if I want to do I could do people list equals $ls ... Okay, well that's a bit crummy, but let's do /home /tc011 /tc011. Okay, that, yeah, will set people list to be the people that, remember, there's a directory for every person in that thing. And what I will do is so you build these things up. Don't do it all at once, right? Let's check that the people list. Do people understand why that works? If I do, if I cat people.show, okay, right. If I do ls /home /tc011 /tc011, I get that list of all the people on the course, okay? If this syntax here says set people list to the output of that command, and then I'm echoing it, right? So let's chmod plus x /people, and let's run it. So the list of people is that it's exactly the same as I got with the LS, except it's stripped out it's no longer formatted it. So it's interesting actually that if I do ls that, it's nicely formatted. Yeah. Okay. If I pipe that into something like cat, it's multiple lines, but if I do into a variable, it has no new line. So it kind of does what you'd expect to be the right thing. Okay. So that is the list of people I want. Okay. Now what I want to do is for person in, I'm supposed to use uppercase letters, aren't I? Person in $people list. Let's just do echo user is, I'm being a bit $person. I'm being a bit pedantic here, but I do like to build these things up because I'll just go, let's now run that. Yeah, the user is, we have all the users here, okay? The reason why we need to be careful is that this isn't a compiled language. If we make typos, yeah, if I do $person, yeah, it doesn't complain. It doesn't say there's no variable called person. It just runs and I get nothing, okay? So that's one of the disadvantages of interpreted programming like Bash. You know, if you do a typo, it doesn't, there's no compilation stage, so it doesn't syntax check it or anything like that, okay? But anyway, that's, so what I want to do is I want to do who piped into grep $person, okay? So what that's doing is it's looping over all the people on the course. It's using who, which lists everybody who's on this login node from the course, and it greps for that person to see if they're there. So will this do the right thing? I'm clearing my screen. So it says that HJT COJ Clark, Tomato Roundwood, T and me are all on this node, okay? So that was interesting. However, Luciana's missing from that list. I thought you were on this. Oh. Ah, okay. Okay. So the important point is there is no user called Luciana in a if list, because Luciana's in a diff. You were previously logged in as in your N02 account, so that didn't appear in this list. This is a list of people in TC011. Yeah. Okay. Sorry. So that's the kind of thing you can do. You know, that's a, you know, you can do. These are useful things to do. Yeah. I can basically, that's a script which now tells me who people on the course are in my who of you is on the course on the same login node as me. So it's not everybody. And if you look at the actual text from the I'll maybe switch now and we can go through these things. Okay. So this is the standard loop syntax which I talked about. Okay. So as it says, when a for loop gets run, every time the value of R is set to first, second, and third, and then you can get its value with the $. Okay. And that was then this is a similar thing I did here. I then said, well, instead of set files to be something useful, which is like the output of the ls command, and we can loop through that, and that would list all the commands. We could do for var install.gz, okay, echo $var. So for example, what I could have done is I could have said, I actually only want to know all the users whose names begin with R, for example. So the way I could have done that, if I could just share a different file again, this swapping is not particularly elegant, I appreciate. if I run people.show, it says that there's quite a few people there. I could pipe it into word count. It means there's 8 people, okay? But I might only be interested in the people whose names begin with R. So I could then say, okay, ls/home/r star. So only list the people in that directory whose names begin with R, okay? And then I could do that. So that might be /people.show. Now I only get okay. Okay. Haha. So okay, what it tried to do was actually list all the directories, and it couldn't, okay, because it said that okay, so this is so what I have to actually do that kind of work. This is okay. I've bitten off more than I can chew, actually. So so okay. So that wasn't a very good thing to do. So I will. Yes. Okay. Apologies. I kind of bit off more than I could chew. I could probably do it with this. If this doesn't work, I'll just give up and hang my head in shame. No. So this is where I shouldn't have tried to do this on the fly. I was trying to do so. Okay. Okay. So I over stretch myself there. I should have to think about this. I could probably do it in a. Yeah. Sorry about that. I've kind of overstretched myself and tried to do it live, which was a bad thing to do. But you can, so it works for everybody, but I'm slightly not elude my bash skills to be able to subdivide that. So what you would need to have to do is ls. That's the problem we got. Fine. Okay. So I mean, we can -d just listing is there. That's not going to help us because we've got these horrible dots. I'm going to have to think about that. So I shouldn't have tried to do that on the fly. But in fact, if you look at the example, so that's clearly why I should have stuck to the script, because the script has been designed to be correct as opposed to my extemporation. It is not correct. I will. If you wanted to loop over all the files beginning with gz, you do for var install.gz echo that, okay, and then you'll get all the bash lessons. And so the actual examples here were to print a loop to print on the name and top 4 lines of every FASTQ file in the directory. So what you want to do is to go there and then loop over every file and cat it and pipe into head -4, okay? And that's what you do here, head -n4 file for file in the star.fastq, okay? Or you could restrict it to be like that, okay? Then also you can, this is the way we talked about, you know, we can basically we can append things. Now this is where it gets slightly more. Yes, I think so. Julian's giving me some code which would work, but you'd have to run that in the right directory. That's why I was hesitating. Otherwise, you get it's. I was doing a bit of a hacky thing there. So Julian's come up with a solution, but I think you probably have to run it in the right directory, which is the maybe that's what you did there. But that was what was stumping me, I have to say. So this is an interesting thing here. So file equals stuff.txt echo $file.example. Okay, why do we need these? We haven't seen this syntax before. Why do we need these braces here? Okay. Without that, what would happen? If I didn't have these braces, then it would look for a variable called file.example. So I tend to actually use these braces all the time because this says the value of file and then put .example on the end, okay? So for example, stuff.text.example. And so to be honest, a classic thing that I would do in a kind of a real example, and I promise this is the last thing I'll do, and I hope I'm going to get it right, rather than my previous attempts, which weren't very good, is, for example, if we look here, I have all these MPI sharpen outputs, okay? Imagine I want to do a copy of them. I want to have a backup of them all. I would write something like, oops, sorry, I'm not doing this very well. Copy $file to $file dot back. Done. We chmod plus x copy dot show, and then we run it. And now if I ls minus lrt, you'll see that the last it's created, the last however many 20 or so files were created were all the file dot back. So that's why that's useful. If I had done this, it wouldn't have worked. I don't know actually what it's going to do here. Let's see what it does. Oh, the dot, okay, so I was wrong there. The dot did work. It was because the dot, yeah, okay. I think it stops at the dot. There are various rules for this, but I would always put in explicit braces. So apologies, I'm showing up my ignorance for the details of Bash here, but I would always do this because that is unambiguous. So I tend to, when I write Bash scripts, to be rather conservative and always put the put in these explicit quotation, explicit braces. So there's a little bit at the end here about how to use permissions, where you can specify permissions numerically rather than this chmod syntax. Oops, sorry, I'm going to have to share the directory again. So you can specify these numeric values instead of using chmod plus x. You can specify exact examples, and this explains what those are. I have to say I don't like that syntax because I actually did something. I typed in the wrong number and I was unable. You can type in things which are meaningless and really mess things up. And I have a file lying around in one of my directories that I can't for the life of me get rid of because I messed it up with the chmod. So I like the syntax chmod plus x, which is, add execute come up. But you can, if you're brave, give these numerical examples. And this section here explains how to convert the read, write, and execute permissions into these numerical values, which are between 0 and 7. And so this says give both read, write, and execute values of 7 to user group and other, which actually means read, write, execute for everybody. But if you put in random numbers there, you can get files which don't make any sense. So I tend to avoid that. So apologies for all my attempts at doing things on the fly, which didn't always work. But the key points are a shell script is just a list of bash commands in a text file. If you find yourself commonly typing 4 or 5 commands in a row, the classic thing in Unix is to put them into a command file and then run them all as one. And you need to give it execute permission. And why this is really important for tomorrow is when we submit a job to a queuing system or a supercomputer, which might run in a day, a week, an hour's time, we don't know. What we do is we submit a batch script which lists everything we want to do, and that is executed as a oneer. that is executed in its entirety when it gets to the front of the queue. So understanding how scripts work is a first step to then running batch jobs on a supercomputer, because what you submit is actually a script which is then executed on the remote resource. So I've slightly hope I managed to make it through that session. I hope it wasn't too confusing. Does anyone have any questions at all about anything today? If people still have any problems with their accounts, questions about anything at all? What we're going to do tomorrow is we're going to start logging. We're going to start running real jobs on Archer, not just going to log on as we have done today. We're going to start running jobs on the compute node during a login node. And we're going to start working in the work file system. We'll start using Archer much more as a real parallel supercomputer rather than just a machine we can run a few commands on. But did anyone have any questions at all? I'm happy to take questions for the next 10-15 minutes if people won't have any questions at all. Yes, so you have to use base name. Yeah, Julian, yeah, to strip things out. I didn't want to go that far, and also it would stretch me beyond my well, no, honestly, you can ask the questions. I mean, you can ask it now, and it might be useful now. If it's more useful to answer tomorrow, I'll answer it tomorrow. But I think it might be. It's worth asking things up front so they can. I know what I need to concentrate on tomorrow as well. Okay, so you won't. We can maybe stay afterwards, Deirdre, to try and sort that out. So you won't be able to run things like QSub, and you won't be able to experiment with running real parallel jobs through the batch system because that isn't set up. So I think that we should maybe go back to that. So yes, so Deirdre, no, you don't need to be on a VPN. You don't need to be on a VPN. You're just logging in. So yes, as Julian was saying, we do use systems for installing software. SPAC was one we use on Cirrus, but I don't know if it was Julian or a colleague, William, who did an evaluation. William did an evaluation, and he found that for our purposes, Easy Build was probably a better solution. But yes, we will be using a build tool system, and we'll be using Easy Build at Archer2. Deirdre, I don't think you need to be on a VPN. I mean, are you logging in from? Yes, you're saying you're just logging in from home, aren't you? Yeah. Okay. So what we'll cover tomorrow is, I mean, the difficulty you have, as I said, you type a command on Unix, and it has a default search path, which we'll talk about tomorrow, and it just runs the first one it finds. That's not very useful if you have 6 versions of GNU compiler installed. How do you pick which one? And so the module system is really the way that a user interacts. It's unlikely you'll be installing your own software. Well, not unlikely, but it's not the normal situation for most users. The software is installed, but they need to select the right version, and we do the version selection by using modules. Lmod, I'm not sure if it's like Lmod. What is that Lmod? Yes, it sounds like that, yes. Yes, there is. I mean, there are, yeah. So yeah, and we'll talk about that tomorrow, and it's modules. It is really just a way of messing around with your path, and we'll talk about that tomorrow. But from a user, it gives you a cleaner interface to software selection. Okay. I mean, in terms of installing software, the reason that Anis, to install software centrally, of course, you need root permission. You need to be super user. You can install software in your own directory, but you need to have super user access to install software centrally for all users. And one of the issues is that although you have admin privileges on your own laptop, you're not going to get admin privileges on a machine like Archer. So it's not possible for or easy. It's not straightforward for a user to install software which is available to a group. It is possible. So you can build your own software, but I guess we are recommending easy build on Archer2 even for users. I think I'd need to speak to William about that, but we will discuss installing your own software on Archer tomorrow, but at quite a basic level. We'll talk about selecting system modules and selecting the right software with the module system. We'll briefly cover how you install software yourself, but we'll just do it by hand build. We won't cover easy build, but there was a seminar given on easy build, and I think it was probably recorded. I wasn't attend due to teaching commitments, but I think Juan was there. So there is actually a I'm sharing this, aren't I? If I go to, I can just find, I'll maybe find it online if I go to website. So all the training is archived, training materials repository, and you'll see that software package HPC with SPAC and easy build was done online a couple of weeks ago. And so actually William covered both. The slides are there and there's a video of it. So if you're interested in how the two compare, I think that'll answer your question, what we decided. So William evaluated both. So that's, you can find it from the website, but it's just there. But all this stuff is shared under, is available under training courses, training materials and past courses. In fact, the search, does this work? Yeah, there it does. So even the search finds it as well. That's well indexed. Yeah. So you have to know it's there first of all. But that was one of an ongoing series of virtual tutorials that Juan has been in charge of organizing. So oh, I didn't mean to do that. Not that I went. So what we'll do tomorrow, just to briefly, I need to navigate this, is tomorrow we'll talk about why use a cluster, we'll talk about how it's different, and then we'll go on to this will probably be done quite quickly because we've covered some of it today. Then we'll talk about scheduling jobs, accessing software, transfer files, using resources effectively, and using shared resources responsibly. So really that's how to be we're not going to cover how to write. We're going to run parallel programs, and we're going to look at their performance if we get that far. We're not going to talk about how to write parallel programs because that's really lots of other courses on that. But this is going to show you how to use Archer. I think the important point is, although this is Archer, and a lot of what we're doing will be the concepts that are applicable generally, the specifics might be specific to Archer, but it will feel more like Archer2. I mean, there are some differences. We're using a different scheduling system, but I think using Archer is a good, if you've not used an HPC system before, if you can learn to use Archer, then when you go to Archer2, it will be relatively familiar. Some of the quirks will be the same, separate work and home and other bits and pieces. So that's why we decided to use Archer and not well, we couldn't use Cirrus because Cirrus only came back into service a few days ago, and that wouldn't give us enough time. Okay, so thanks everyone. You must be bored of listening to me, but get more of me tomorrow. We'll just be starting at 10 o'clock tomorrow.